Welcome to the UGC EPG Pathshala lecture series in computer science. In the series of lectures, we have been looking at a subject, database management system, and for today's module we will be looking at normalization, which will be continuation from the previous session. Some of the learning objectives of today's module include: how would a relation appear in an unnormalized format, and how would it, what property is to be satisfied to convert it into a first normal form, and likewise every property required to convert it into appropriate normal forms. Although we have several normal forms, 7 normal forms totally we have, but then we will be looking at 3 normal forms for today's module. Transitive dependency. We will look at the definition of transitive dependency. A transitive dependency exists when there is an intermediate functional dependency, that is, by formal notation we will look at. We have already seen functional dependence. A determines B, that is, B is functionally dependent on A, and B determines C, that is, C is functionally dependent on B. By looking at these two relations, we can say that the following is transitive dependent, and there exists A that determines B and B that determines C. If you look at in the reverse way, A is transitively dependent on C. We will look at this particular notation with an example. Now we will consider a relation staff number, job, department and department name. So these are the transitive dependencies that exist. If you look at the relation staff number, job, department and department name, there seems to be some repetitive information that is available. Let us not find out those repetitive informations as of this transitive dependency is concerned. But then if you look at department, department is functionally dependent on staff number. Department name is functionally dependent on department. So this has been highlighted. So we can say that if you consider staff number as A, department as B, department name as C, department is functionally dependent on staff number, which is pretty much acceptable because staff number is supposed to be the primary key of this particular relation, and department name is dependent on department. So A determines department, staff number determines department, department determines department name. So we have highlighted saying staff number determines department and department determines department name. Many a times we would have looked at this particular example. A implies B. If A implies B, B implies C, can that be inferred as A implies C, which is supposed to be called as transitive dependencies here. So department name is dependent only on department and not on staff number. So we are taking out department name and creating a new relation like department with department name as a separate relation, and not staff number, department, department name to be involved. So this is supposed to be called a transitive dependency. So we are ensuring that no relation has, or there are attributes of a particular relation, and we are trying to remove atomic value, or we are trying to remove repeating groups, we are trying to remove partial functional dependencies, and we look at whether there exists any transitive dependency. So by way of removing transitive dependency, we are making sure that a new relation is being created. So as normalization, as we have indicated in the previous session, in order to comply with the relational model, it is necessary to remove repeating groups and avoid redundancy and anomalies by removing partial and transitive functional dependencies. As far as relational database design is concerned, all the attributes in the relation must be purely atomic and solely dependent upon fully primary key of that particular table. So, these are the various stages of normalization. From an unnormalized format, we may have to remove repeating groups, which makes it to a first normal form, and by removing partially functional dependence, we will make it to second normal form. That means, we ensure that between first normal form and second normal form, we have all attributes which are fully functional dependent, and by removing transitive dependencies, we make it to the third normal form. Removing remaining functional dependency anomalies, we make it to an intermediary concern, which is called Boyce-Codd normal form, and by removing multi-value dependencies, we will make it to fourth normal form, and by removing the remaining anomalies like joint dependencies, we will make it to the fifth normal form, and we make sure there exists a domain key by where maybe we make it to a domain key normal form. So, totally we have first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form, and DKNF. Totally we have 7 different normal forms. At the maximum, for any specific relation, it will be ensured that it has been taken care until third normal form to the major. Let us look at each and every normal forms in detail. We will try to initially find whether it is in an unnormalized format. A relation is said to be in unnormalized format when it has not had any normalization rule which are applied to it. As such, it is being considered as a relation and it does not have any normalization rules that are specifically applied, and it suffers from various anomalies. So, it is not mandatory that it has to suffer from anomaly. We check whether this particular relation has got any anomalies involved. So, this only tends to occur where the relation has been designed using bottom up approach. That is, it has to capture all the attributes to a universal relation from the screen layout, manual report, manual document, etc. So, this is a particular unnormalized form relation where a customer places an order and it is not one specific product that he will be purchasing, it will be a list of products. So, this is typical of a invoice kind of a thing, where it involves customer number, customer name, address, order number, order date, and a list of products that he is tending to purchase and the total amount that he will be purchasing the items with. If you consider this unnormalized relation, if it is to be converted into a relational database, it involves these as the attributes. From the beginning, order number, order date which is specific to every order is considered. Further, customer number, customer name, customer address, product number, product description, unit price, order quantity, line total, and order total. So, whatever that is available in this particular order invoice, each and every attribute or each and every value of this particular invoice is considered as an attribute for the relation that we are about to construct, and this list of relations is being given with a name order. How can we make it to a first normal form? We will tend to define every normal form initially and we will give steps how to convert to a normal form. A relation is said to be in first normal form if and only if all its underlying attributes contain atomic values only. As I have already indicated what an atomic value mean, by where from an unnormalized table to a first normal form, we ensure that all relations has atomic values only. So, it means we may have to remove repeating groups into the new relation. So, a repeating group is shown by a pair of brackets within the relational schema, that is whatever that we have highlighted in the red is supposed to be a repeating group on the invoice that we have considered. For a specific customer, for a specific order, there are a list of products that a customer tends to purchase. So, this becomes the repeating group. So, we have highlighted that particular repeating group by a star on top of it, and now that we may have to take it to a new relation. So, after having highlighted, we will see what are the steps that are to be done to convert unnormalized table into a first normal form. The first thing that we may have to check on an unnormalized relation is remove the outermost repeating group or any nested repeating groups it may contain, and create a new relation to contain it. Add to this relation a copy of primary key, because whenever there is a query from an external world, it does not understand that this relation has been split into 3 or 4 relations after performing this normalization. But then the query that the user tends to acquire with will be posted as a query, and this will be in turn considered as a different segment of a query. So, for which every relation should be carrying its primary key what has been assigned originally. Further, after having split into this particular relation, this table can have its own primary keys. So, add to this relation a copy of primary key of the relation immediately enclosing it, name the new entity, determine the primary key of the new entity. The actual primary key which was assigned for the order table need not be the primary key for this table also. There can be composite keys that can also be involved. Repeat these steps until no more repeating groups available. So, after performing the first normal form, we make sure that there are no more repeating groups available. So, we may not have to check any more repeating groups after performing the first normal form. We will go back to the actual relation that we have considered, where we have highlighted the one that are repeating with a star. Now, we apply the first step, remove the outermost repeating group and any nested repeated groups that it may contain, and create a new relation to contain it. Now, that we have segregated those values that are found to be repeating into a new relation, that is product number, product description, unit price, order quantity, line total is being considered as a new relation. Now, the actual relation that had a group of attributes now got split. So, the original relation is being split as order 1, that is after performing first normal form. This order relation has got only this list of attributes, but then a new set of attributes are considered for the new relation. As a step 2, what we have considered is add to this relation a copy of a primary key immediately enclosing it. So, from the original relation we consider the primary key of that particular relation to the primary key of this relation. Now, if I am issuing a query to this particular relation, we may not understand that this relation is split into 2, but by basically referring to the order number, it will be listing all the products that a particular customer has purchased. So, order number is being the primary key as such in this particular relation. Now, we may have to name the new entity. Now, that I say this new entity as order line 1, which has got order number, product description, unit price, order quantity and line total. And now, I may have to understand the primary key of this new entity, where order line 1, product number and order number together becomes the primary key for this new relation. So, it is not just that order number alone makes it to the primary key of this relation, but then order number and product number together makes it to the newer relation. So, after performing from an unnormalized table to the first normal form, by where we have made sure that there are no repeating groups that is available with this particular relation, and we have completely made sure that every value in this particular relation is atomic. So, it has been made sure by performing first normal form there are no repeating groups or nested repeating groups that is available within this particular relation. Now, we tend to move for the next normal form, which is second normal form. A relation is said to be in second normal form if and only if it is in first normal form. That is, I am making sure each and every normal form goes through a process of first normal form, then it has to go through second normal form, then it has to go through third normal form, which means everything is related within it. So, if and only if it is in first normal form and every non-key attribute is fully functionally dependent on the primary key. As we have already indicated in the previous session, there has to be a relation which should be fully dependent on the primary key. So, I may have to remove, which indirectly means I may have to remove partial functionally dependent relations into the new relation. So, the steps that are to be taken care when we perform from first normal form to second normal form: remove the offending attributes that are only partially functional dependent on the composite keys and place them in a new relation. Add to this relation a copy of attributes which are determinants of these offending attributes. These will automatically become the primary key of the new relation. Name the new entity and rename the original entity. So, these are the steps that are to be taken care when we wanted to perform a shift from first normal form to second normal form. So, the table that we may have to consider when we are about to perform second normal form is order line 1 table, which is the table that we have found some repeating groups available. So, we will check for both the tables. Order 1 table is the first normalized table which is from the actual relation, and order line 1 is supposed to be the repeating table that is available from the actual table. Now that we do not find any partial or full functional dependencies in the any partial functional dependent in the order 1 table, we find some partially functional dependent relations or attributes exist in order line 1 table. So, we are considering order line 1 table where if you look at product description is not dependent on order number and product number, instead product description is dependent only on the product number. So, that is one specific example. So, we may have to remove the offending attributes that are only partially functional dependent on the composite key and place them into the new relation. So, I look at these two attributes like product descriptions and unit price is dependent only on product number and not on order number. So, I take out product description and unit price from order line 1 relation. Now that I want to make it as a separate relation, but then to make it as a separate relation I need to have a primary key which has actually been or which was actually in the original relation. So, by taking out product number from this original relation, this will make it to a full functional dependent. Now, if I look at order quantity is dependent on order number and product number, line total is dependent on order number and product number, whereas product description is dependent only on product number and unit price is dependent only on product number. So, by where I am removing all the partially functional dependent relations or attributes from the original relation and making it fully functional dependent. So, add to this relation as a step 2, we will make add to this relation a copy of attributes which determines these offending attributes. These will automatically become the primary key of the new relation. So, I am taking out product number from the original relation, and now that product number, product description and unit price becomes a separate relation where product description is fully functionally dependent on product number, unit price is functionally dependent on product number, order quantity is fully functionally dependent on order number and product number, and line total is fully functionally dependent on order number and product number. So, now after performing this second normal form, we have converted the repeating groups table and we have divided that particular table into two different relations like order line 1 and product descriptions. So, now that we may have after creating a new relation, we may have to name the new entity. So, the new entity with attributes like product number, product description and unit price is named as product 2, whereas the actual relation that we have considered, that is order line 1, has got reduced set of attributes now. So, we may have to rename the original entity also. The original entity has got now only 4 attributes, then it becomes order line 2, that means it is the resultant of second normal form. So, by second normal form we have made sure that there are no partial functional dependencies and every relation or every attribute of this particular relation is fully functionally dependent on the determinant. Now, we will look at the third functional or third normal form. A relation is said to be in third normal form if and only if it is in second normal form and every non-key attribute is non-transitively dependent on the primary key. That means, we are about to remove the transitive dependencies into the new relation. Some of the steps that need to be taken care when we want to do a third normal form. Remove the offending attributes that are transitively dependent on the non-key attributes and place them into a new relation. Add to this relation a copy of attributes which are the determinants of these offending attributes. These will automatically become the primary key of the new relation. Name the new entity, rename the original entity. Now, we will go back to the actual table that we have considered. We will go for the order table. I have renamed the order table after having performed the second normal form. It is actually order 1 table, but after performing or after getting into second normal form we had renamed this renamed relation as order 2. If you consider this relation, attribute order date is dependent on order number, customer number is also dependent on order number, whereas customer name is not dependent on order number, it is in fact dependent purely on customer number, which is not a key attribute. Customer address is also not dependent on order number, it is dependent purely on customer number, which is not a primary key. Order total is dependent on order number. So, if you look at this particular relation, I am segregating customer name, customer address from this original relation, where I find these two attributes are not transitively dependent on the original relation. Instead, it is dependent on some other attribute. That means, customer name is dependent on customer number, customer address is dependent on customer number, not on order number. So, this is actually a transitive dependent. So, from the original relation, that is order 2 relation, we have taken out customer name and customer address. To make it to a separate relation, we are inserting customer number on top of it, which makes it to a primary key. Now, that we may have to name the new entity. By looking at all the customer values, we are making it to customer 3 relation with a relation name customer 3, that is after a third normal form, and the original relation now got reduced with a limited attributes and has been renamed as order 3 relation. So, after performing this normalization of from the unnormalized format, we have tried eliminating repeating groups, we have tried eliminating partial functional dependencies, and we have found transitive dependencies. After performing 3 different normal forms, a relation which had a list of attributes from an unnormalized format is being divided into many relations. It is not one specific relation which was derived out of a particular normal form, it is multiple relations has been derived. So, after performing 3 normal forms, this relation of order is being divided into 4 relations: order 3, customer 3, product 2 and order line 2. This relation of product 2 and order line 2 has not been changed after second normal form, whereas a relation of order 3 and customer 3 went until third normal form. So, if you look at all the 4 tables, it is somehow related by the primary key. Order number is related to order number and product number of order line, and product number of this relation is related to product number of other relation, and customer number is mapped with order 3. So, each and every relation has got a link or the primary key link associated within it. By the primary key, when we get a query, it will initially get into order table and it will find appropriate tables that has been mapped with, and finally it will acquire its value from the order table from the individual tables and make it to a ordered table. So, after performing the operations of various normal forms, that is first normal form, second normal form and third normal form, by looking at all these 4 tables, we make sure that this relation does not have any repeating groups, does not have any partial functional dependencies, and it is not transitive dependent also. So, as a summary of this particular session, we have started with normalization and we have started explaining about transitive dependency. Then from an unnormalized relation, we have shifted to a first normal form. Then we have landed on a second normal form by removing partial functional dependence. From the second normal form, we have shifted to a third normal form by removing transitive dependence. Thank you.